9.3a, starting logarithmic functions. So we're going to start evaluating logs today. And this is really the first introduction to logs. And so let's go over the operations you're familiar with and talk about the inverse. So the inverse of adding is subtracting. You know the inverse of multiplying is dividing. The other ones that maybe not so familiar with is like if you have a square, like an x to the square, the inverse would be the square root. The square root. So exponents in general, the inverse is roots. So if you have a cubed root, then the inverse would be to cube it. And today we're going to go with exponents, roots, and then logs kind of go together with exponents and logs as well. So logs and exponents kind of go together. And we need logs because we know that, we know 2 squared is 4, and we know 2 cubed is 8, but 2 to what power is 6? So we use logs to help us solve this type of problem here. We know that it must be a number between 2 and 3 since 2 squared is 4 and 2 cubed is 8. Then we know that if we're between 4 and 8, then 2 to some power has to be between 2 and 3. But how do we find it? And to answer that, we use logarithms. So logarithms go along with that. A logarithm is defined to be how many of one number do we need to multiply to get to another number. So 2 to the x equals 8. Basically, this says, so if we think about it in logs, so how many 2's do we need to get to 8? Do we need to get to 8? So how many of one number do we need to multiply to get to another number? So how many 2's do we need to get to 8? And the answer is 3, because 2 cubed is 8. So that means that it corresponds here, 2 cubed is 8. So then the log of 2 of 8 equals 3. So see how these kind of correspond together? So the log base 2 of 8 is 3. So definition of logs is right here. Log base b of y equals x, and that's the same thing as b to the x equals y. So you can go back and forth between those two expressions. The b is the base in both. So like when you had 2 to the third equals 8, that's log of base 2 of 8 equals 3. And I always remember it this way. This is your b, 2 to the third power then equals 8. So 2 to the third power equals 8. And so you can kind of go back and forth. You have to have b greater than 0, y greater than 0, and you can't have b equal to 0. So you can't have a base of 0 for these to work. Those are a couple of restrictions. So just practicing writing, going from log base b of y equals x, then it's going to be b to the x power equals y. And I kind of do this little circle here, b to the x equals y. So b is the base in both. So this one would be 2 to the 5th power equals 32. And that's true, 2 to the 5th does equal 32. Log base 10 of 1, over here this is 10 to the 0 power equals 1. So rewriting it in exponential form. 9 to the 1st power equals 9. 1/5 to the negative 2 equals 25. So that's a negative exponent rule. And we can go backwards as well. So 4 squared is 16. Well, that's log base 4 of 16 will equal 2. And you can see 4 to the second power equals 16. It works out. So we're just going backwards now. The base, the 2 cubed, equals 8. 2 is the base, and 8 is what it equals, so that's your y. So this is going to be log base 2 of 8 equals 3. Or log base 2 of 1/8 equals -3. It's -3. So just going back and forth between exponential and log form. So it just takes some practice, but I like to use the arrows to remind me that I go from the b to this power equals what's inside. So then we can evaluate these if we know that you have to raise it to some power. So this is really like 3 to what power here? What power equals 81? And then I know that 3 to the, 3 cubed is 27, and 27 times another 3 is 81. So 3 to the 4th is 81. So this one equals 4. So log base 3 of 81 is equal to 4, since 3 to the 4th equals 81. So using those exponential and logs, kind of going back and forth. 1/4, we can maybe let this equal x and then solve for x. So 1/4 to what power will equal 256? Let me erase this over here. So since I have a fraction and raised to a power and it equals a whole number, I know that my exponent must be negative because I'm going to have to reverse this. I need 4 to some power equals 256. So to do that, my x is going to be negative something. So 4 to what power is 256? So how many 4s? Well, I know that 256 is 16 and 16, and then that's 4 times 4, 4 times 4. So 4 to the 4th is 256. So 1/4 to the -4 will be 256. So 1/4 to the -4 is really 4 to the 4th, which is 256. Which means that the log base 1/4 of 256 equals -4. When you work with base 10, 10 to what power equals this decimal? So 10 to what power equals 0.001. Remember when you work with a base of 10, if you think about scientific notation, my decimal is behind the 10, and I can move it over 1, 2, 3, 4, and then I get 0.001. So that means I had to go 4 to the left, so that this exponent has to be -4. So that's how I figured that one out. 10 to the -4th power would equal 0.0001. So log base 10 of, let's be tenths, hundreds, thousandths, 1,000th is -4. 64 to what power equals 2? Well, 64 to what power equals 2, since I'm going from a large value to a smaller value, that means I have to think roots. It's like, what root of 64 equals 2? Remember, I can go back and forth between exponents and roots. So if I break down 64, that's 8 and 8. How many 2's do I need here? How many 2's is 64 is what I meant to say. So 1, 2, 3, 4, 5, 6 2's. I would need a group of 6, which means that really this would be the 6th root of 64 equals 2. Then remember that the 6th root of 64, that is the same thing as 64 to the 1/6 power. So the 6th root of 64 equals 2, so it'd be 64 to the 1/6 power. So that means that log base 64 of 2 equals 1/6. So if you're going from a fraction to a whole number, you should think, oh, my answer has to have a negative exponent, like in this example. So I went from 1/4 to 256. So I had to have a negative exponent. If you're going from something large to small, then it has to be some sort of fractional exponent or a root. There are a couple special logarithm values, like the logarithm of 1. If you have any base and you have log of 1, it always equals 0, because it doesn't matter what your base is, but if you have log of 6 of 1, log base 6 of 1, it's going to equal 0. And the reason that works is because you take 6 to, or the base, any base, but this one's 6, to the 0 power, it always equals 1. So anything to the 0 power is 1. So anytime you have a log evaluated of 1, it equals 0. And then the other special case is if you have a log base b of b, it equals 1. That's like if you have log base 6 of 6, it equals 1, because 6 to the first power always equals 6. So anytime those logs double up, like log base 8 of 8 is 1, because 8 to the first equals 8. So anytime those double up, it equals 8. Then we have the common log, and that's the log that you see in your calculator. It's just log of x. That's log base 10, and it's called the common log. So log of x really is log base 10 of x. We usually just write it as log of x, so you don't see the 10 there. And then we also have the natural log, and that's a logarithm with base e. That one we use ln. So the common log is log base 10 of x, just found in your calculator as log of x. The natural log is log base e of x, and that's the ln, the natural log. So you'll see the two calculator buttons, one's log of x, one's ln of x. So you can use your calculator to evaluate those common and natural logs. So some we can do without a calculator, like this. I'll number these so I can refer to them easier. Whoops, that'd be 3, 4, 5, 6. So number 1, that's 4 to what power equals 64? Well, 4 to what power equals 64? I think there was 3. 4 cubed is 64. So log base 4 of 64 is 3. And number 2, we already did that one. 1/4 to the negative 4 would be 256, so negative 4. And number 3, 2 to what power would equal 1/8? So 2 to what power equals 1/8? Since I'm starting with a whole number, I'm turning into a fraction. That means it has to be negative, because 2 to the negative power will be 1 over 2 to the x. So 2 to the third is 1/8. So that means that this is negative 3. 2 to the negative 3 equals 1 over 8. 32 to what power equals 2? 32 to what power equals 2? Since I'm going from a large value to a small value, that tells me I need to have a root here. So really I'm thinking, what root of 32 will be 2? So there's 5 2's, I believe, in 32. If you think about 16 and 2, 4 and 4, 2, 2, 2, 2. So there's 5 2's. So 2 to the 5th is 32, or 32 to the 1/5, the 5th root of 32 equals 2. So that's that one. Now log base 10 of 7. So this doesn't have, it's a common log. So it's 10 to what power equals 7. That one's going to be a decimal. So you had to use a calculator for that. So I downloaded a calculator. Where did I put it? Right here. So you'll just find the common log button like that. So log of 7, I think it was, equals, let's see, log of 7. I don't know how to work this calculator. So log of 7 equals, I want it to evaluate, there we go, 0.845, so it's approximately 0.845. And it continues to repeat. And then the ln, this is really e to what power equals 1/4 or 0.25. So there's a button in the calculator, the natural log button, and you should be able to find it. It should look like, oh, okay, nope. Okay, there we go. ln right there, ln of 0.25 equals negative 1.39. Negative 1.39. There you go. So the bottom two are just in your calculator since you can't figure them out without a calculator. Okay, I think that's it. So today's lesson was all about practicing this and being able to go between log and exponential form. And then we have the two that you need to remember. The common log, if you don't see the base, it's the log base 10. And then we have the natural log, which is log base e, which is ln. So those are the two that you have to memorize. And then we want to just practice going back and forth between log base b of y equals x to b to the x equals y. So being able to go back in between exponential and logarithm form. All right.